In this video, we are learning how to interpret box plots. So the first question you might have is, what is a box plot? So I'll give a definition here. A box plot is just a graphical representation of the spread of a particular data set based off of its 5-number summary. Second question you might have is, what is a 5-number summary and what are the 5 numbers? So first, let's draw what a typical box plot looks like. It is a box, hence the word box plot, with a line somewhere in the middle or near the middle, and then 2 whiskers going out like that. It also can be known as a box and whiskers plot, with the whiskers being that red line out there and that blue line on the right. So like I stated earlier, this is based off of a 5-number summary, and let's go over what each of these 5 numbers are. So you're going to have the whiskers here on the left is going to be the minimum, and then you have Q1, the median, Q3, and then the number on the right is going to be the maximum. So let's give a little definition of each of these. So the minimum, as you might guess, is going to be the smallest number in the data set. Q1 is going to be the number in between the minimum and the median. The median is going to be the number in the exact middle of the data set. Q3 is going to be the number in between the maximum and the median. And then the maximum obviously is going to be the biggest number in the data set. So for this to make more sense, let's go ahead and take a look at an actual data set, and we're going to break this up into a 5-number summary and a box plot. So the minimum number in this data set is going to be 22. The maximum is going to be 62. And now we got to find the median. So first find the median before Q1 and Q3 because you have to. So to find the median, the exact middle, we're just going to count in equally from each side. So there's 1, 2, 3, 4, 5, 6, 7 numbers on each side, so it's equal, and then that number directly in the middle, the 8th number in the data set, is going to be 42, is going to be our median. And we're going to actually do the exact same thing to find Q1 and Q3, but instead of counting from the minimum to maximum, we're going to count from minimum to median and count equally on both sides. So there's in 1, 2, 3, and then there's 2 numbers in the middle here, so we're going to actually have to find the average of that. So again, we're going to add those 2 up, divide them by 2. 30 plus 32 is 62, divided by 2. It's going to give us a Q1 of 31. Now we got to do the same thing to find Q3. So again, we're going to count in on equal sides from the median and the maximum. So there's count in 1, 2, 3 numbers on each side. There's 2 in the middle. So when there's 2 in the middle, we got to find the average. So 52 plus 56 divided by 2. So that's going to be 108. Divided by 2, and 108 divided by 2 is 54. So that gives us a Q3 of 54. So now we have all of our numbers we need for our 5-number summary, and we can make our box plot. So let's go ahead and do that. So when making a box plot, you always start with the Q1, median, and Q3. And so if you look at these numbers, 31 is 11 away from 42, and 54 is 12 away. So we're going to move 42 a little bit closer to 31 and draw our median right there. Now let's bring in our minimum over here, and it's 9 away from 31, so it's going to be a little bit shorter distance than from 31 to 42. Now we're going to do the same thing with our maximum, and that's going to be 8 away from 54, so we're going to draw, again, it's going to be the closest distance is 54 to 62. So that is our completed box plot, but there's also one other thing you must take note of, is that there's actually going to be the same amount of numbers in between each label point or each number in the 5-number summary, and there is always going to be 25% of the data in each quartile. So let's take a look at what that means. So in this first quartile between the minimum and Q1, there's going to be 25% of the data in there. Between 31 and 42, there's going to be 25%. Between 42 and 54, there's going to be 25%. And between 54 and 62, there's going to be 25% of the data. So no matter how weird looking the box plot is, just know there's always going to be 25% in between each of these number ranges. Let's do another example with another data set, and this is going to be a 16-number data set. And again, let's just follow the steps. So first find the minimum, it's going to be 11, the maximum going to be 83, and let's find our median next. So count in from each side. So there's 1, 2, 3, 4, 5, 6, 7, and now there's 2 in the middle, so that means we're going to have to take the average of these for the median. So 30 plus 34 divided by 2 is going to be 64 divided by 2 is going to give us a median of 32. And so now we have everything we need to find Q1 and Q3. So again, let's start counting in. Since there's 2 numbers in the median, we're going to count in from 30 and count in from 11. So count in 1, 2, 3. Again, two numbers in the middle, so let's find the average. 16 plus 18 divided by 2. It's going to be 34 divided by 2, which is going to give us 17. So we know that our Q1 is going to be 17. Let's do the same thing from our median to max. And again, we counted in from 30 for Q1, so we're going to count in from 34 for the max. So let's count in 1, 2, 3, two numbers in the middle. So again, we find the average. 62 plus 68 divided by 2. It's going to give us 130 divided by 2, which is going to give us a Q3 of 65. And now we have everything we need to create our box plot. So again, start with Q1, Q3, and the median. And again, let's look at the numbers. So 17 is 15 away from 32, and 32 is 33 away from 65. So we're going to actually move this quite a bit closer to 17 here. And now let's bring in our minimum. So it's only 6 away from 17. So again, it's very close to 17. And let's bring in our maximum, which is 18 away from 65. So there is our box plot, but also again, remember that there's still the same amount of numbers in between each label point, even though it looks kind of weird, and that 25% of the data is going to be in each quartile. So let's just do a reminder of that we got 25% of the data is in between here and here, 25% in between 17 and 32, 25% in between 32 and 65, and then 25% in between 65 and 83. And so when that's more spread apart like that, it means that the numbers are more spread. And then when the box plot looks tighter as it does on the left side of it, that means the numbers are going to be closer together there. So let's take a look now. Let's do the reverse, and we're just going to take a look at a random box plot, and we're going to start labeling. So here we know that our minimum is 0, our Q1 is 10, our median is 20, Q3 is 30, and our maximum is 40. So again, pretty straightforward. And we know that 25% of the data is in between here and here, 25% in between here and here, 25% between here and here, and then 25% in between here and here. And when you look at this, this is actually a perfect box plot because all the numbers are 10 digits away from one another. So this is going to be a perfectly even spread here. Because again, the 25% will never change, but sometimes you get some funky looking ones where it's not going to look just even like this. Let's look at another example where it's not an even spread, and let's look at this one right here. So first, let's get to labeling. We know our minimum is going to be 115, our Q1 is 150, our median is going to be 175, Q3 is 190, and our maximum is going to be 200. And we also know that 25% of the data is in between here and here, 25% between here and here, 25% between here and here, and the last 25% is going to be between 190 and 200. So when we look at this, we know that these numbers on the left side are going to be further apart from one another. It's going to be a wider spread, and then the numbers right here are going to be closer together or a tighter spread. So that is pretty much everything you need to know about how to interpret and make a box plot. So let's recap real quick. First thing we learned is what a box plot is, a graphical representation of the spread of a data set. Second thing we learned is what the 5 numbers you need to know to construct a box plot represent. And again, that's going to be the minimum, Q1, median, Q3, and the maximum. And the third thing we learned is that there is going to be the same amount of numbers in each quartile, with that 25% in between min and Q1, 25% in between Q1 and median, 25% in between median and Q3, and 25% of the numbers being between Q3 and the maximum. So, if you're interested in learning more about TurtlEd, visit us at www.withturtled.com.